In one of our previous videos, we did the design and working of a Class A amplifier. We went through and explored all the components, figured out how each of them affected the output, and at last, we explored some of its variations. In this video, we will move further and look at other classes of amplifiers, specifically Class B and Class AB amplifiers. This is the simplest Class B amplifier. Unlike Class A, it uses two transistors as an emitter follower in a push-pull configuration. This is an NPN transistor and this is a PNP transistor. The positive cycle of the input signal will be followed by the NPN transistor. When the voltage at the base of this transistor changes, the voltage at its emitters also changes following the base. And the negative cycle of the input signal will be followed by this PNP transistor. When the voltage at the base of this transistor changes, the voltage at its emitters also changes following the base. During the positive cycle, the voltage at the base of the PNP transistor is higher than its emitter, hence this transistor is in its cutoff region. Similarly, in the negative cycle, the voltage at the base of the NPN transistor is lower than its emitter, hence this transistor is in its cutoff region. Now, you would know that a transistor requires 0.7 volts between base and emitter to turn on. Thus, during the positive cycle, until the voltage at the base is above the cutoff voltage, the transistor is in its off stage, and the output voltage is 0. And when the voltage at the base increases above the cutoff voltage, the voltage at the emitter starts to increase, following the base voltage, until it reduces to below the cutoff voltage. Similarly, in the negative cycle, this transistor is off, until the voltage at the base reduces below the cutoff voltage, and then it follows the base voltage. You can see that the output wave is not similar to the input wave. It has these regions of distortions. They are called crossover distortions, as they are caused due to the switching of the transistors. Now, if we bias the input voltage, such that, when there is 0 volt at the input, we have 0.7 volts at the base of the NPN transistor, and minus 0.7 volts at the base of the PNP transistor. Thus, if the input signal increases, the NPN transistor will turn on and start conducting, and we will have the similar signal at the output. Also, the PNP transistor will be in the cutoff region. And, during the negative cycle, the PNP transistor will be on, with the output following the input. But, you may know that the cutoff voltage varies for each transistor, it depends on its manufacturing and the temperature. If we use a bias of 0.7 volts, it may be sufficient for one transistor but not for other transistors, resulting in distortions in the output. Hence, we increase the bias from 0.7 to 0.8 volts. Thus, we can now be sure that the transistor will be on. As the bias voltage is 0.8 volts, at 0 volts of the input signal, both the transistors will be turned on. Now, both of the transistors will try to control the output for different voltages. This will cause distortions in the output. Hence, we add two small resistors to separate both the transistors from fighting for the output. This is how a Class AB amplifier works. Class A amplifier is an amplifier where the transistor is always on. Class B amplifier is an amplifier where the transistor operates for half of the cycle only. Class AB amplifier is an amplifier where the transistor operates for more than half cycle but less than complete cycle. A Class A amplifier produces little to no distortions because the transistor is always on, but it has very high losses, its efficiency is less than 30%. The Class B amplifier negates this drawback of Class A and has an efficiency of 79%, but it creates distortions in the output. Thus, a Class AB is a compromise between both of them, which has fewer distortions than Class B amplifier and better efficiency than Class A. You may wonder, how do we bias the input signal? We use the PN junction diodes. When a diode is active, it has a voltage drop across its terminals. Let's say this diode has a forward voltage drop of 0.7 volts. And this point of the circuit is at 0 volts, as the signal is at 0 volts. Thus the voltage at this terminal of the diode will be 0.7 volts. And for the other one, the voltage at its terminal will be minus 0.7 volts. Now, any changes at the input will cause the voltage at another ends of the diodes to change with the bias of 0.7 volts. This is how we bias both the transistors. You can also connect the input signal at other terminals of the diode. We also add capacitors to filter any DC from any direction, and to avoid short-circuiting the diodes. This is how amplifier of Class B and AB work. Thank you for watching.